So a few people are not here, so I'm just going to go through briefly these sorts of Hess cycle questions. We've looked at a number of ways of doing Hess cycles, and this way of doing them is sometimes comes up in an exam paper, maybe worth a mark or two. So what you can do, you might be given a number of equations which together can combine to form the overall equation. I'll show you how you do that in a second. And if you work out whether those reactions are going in the forward or reverse direction, work out how many moles of each or how many multiples of each one you need, you can simply add or take away some numbers to get the overall enthalpy change for reaction. So I'm going to do question 1 and 2 here. So question 1, it's taking strontium, reacting with graphite and oxygen to give strontium carbonate. You can't work out an enthalpy change directly from that reaction. You can take strontium and turn it into strontium oxide. Strontium is one of our reactants, so this reaction must be going in the forward direction, and that releases 592 kilojoules per mole. In the second step, strontium oxide that we've made in step 1 is being used up by reaction with carbon dioxide to give strontium carbonate, one of our products. So this one has to be also going in the forward direction because we're producing strontium carbonate, and it's using up the strontium oxide that's been used. The third reaction is using the graphite that's one of our reactants, combining it with oxygen to give carbon dioxide. So they're all going in the forward direction. So all you simply have to do is add those three numbers up, gives you minus 1220 kilojoules per mole. If I show you here as well then that you can cancel out the things that are used up, things that are on both sides of this sequence here. So strontium oxide is used up, so you cancel them out. The carbon dioxide is used up, so you cancel it out. You're left with strontium, 1 mole of that, 1 mole of graphite, 1.5 moles of oxygen gives you strontium carbonate. Question 2 is a bit more difficult because you can't just use 1 mole of everything, and one of them has to go in the backward direction. In question 2, carbon's reacting with steam to give methane and carbon dioxide. So reaction 1 is carbon reacting with steam to give, this time, carbon monoxide and hydrogen. But the only equation here that's got carbon in it is reaction 1. So this whole thing must be multiplied by 2. 2 lots of carbon, 1 lot of steam. 2 lots of steam to give 2 lots of carbon monoxide and 2 lots of hydrogen. I'm going to write that out down here. So 2 lots of carbon, 2 lots of hot water, steam, give you 2 lots of carbon monoxide and 2 lots of hydrogen. Now that comes to 2 lots of 131.3 kilojoules per mole. Step 2 is one of those moles of carbon monoxide being used up, and in that reaction we also react with steam. And the reason I know it's only 1 mole of reaction 2 only goes once is because I only produce 1 mole of carbon dioxide, and it's the only place here that carbon monoxide is being formed. So that reaction must also go in the forward direction, but it's only multiplied by 1. So that's carbon monoxide also reacting with steam to give carbon dioxide and hydrogen. So we now generated 3 moles of hydrogen, 1 mole of carbon dioxide. But in the end we've got to generate methane. The third reaction's got methane being used up by reaction with steam to give hydrogen and carbon monoxide. But we know in the earlier reactions we produced carbon monoxide and hydrogen, and we need to make methane. So that reaction must be going in the reverse direction. So I'll write it in the reverse direction. First of all, put here minus 41.2. And so that this time for step 3 we're going to write the reverse of reaction 3, which is carbon monoxide reacting with 3 lots of hydrogen to give steam and methane. Now I'm going to write that as minus 206 because it's the reverse of reaction 3 over here. Now if we check to see this has worked, we've got 3 moles of hydrogen produced and then used up, so they cancel out. We've got 2 moles of carbon monoxide produced but then used up. We've got 3 moles of steam being used and 1 being used up, so we cancel out one of them, and then we're left with the balanced equation that we're supposed to have, which is 2 lots of carbon, 2 lots of steam, gives to carbon monoxide and methane. Add those numbers up together, you get plus 15.3 kilojoules per mole. So that's how you do those. I'm leaving the class to do question 3 and the one that's over here, which is from an IB paper.